All right, in this video, we're going to talk about determining the length of an arc. So the situation that we have is a circle, right? And the circle has some radius. And what we've got is an angle that is a central angle. That is the vertex of the angle is at the center of the circle. And so that angle is going to cut off a part of the circle, right? And so that part of the circle is called an arc, okay? And so what we want to be able to do is find the length of that arc given the radius of the circle and the measure of that central angle there. So if you think back to the Radian video where I told you how to measure an angle with Radian measure, at the very beginning we talked about putting a circle such that the center of the circle was at the vertex of the angle, and then measuring this part around the length of that arc that's cut off by that angle. And then the radian measure, right, was we took this length of this arc and divided by the radius, okay? And so this formula, S equals R theta, just comes straight from that definition of radians. So how you would find that arc length, right, is the arc length is equal to the radius times the measure of the angle, but there's one huge catch that you need to be aware of there, and that this formula only works if the angles is measured in radians, okay? So if you have the radian measure of the angle, then you just throw it right there in the formula in the radius, and that's it. So not very difficult. The thing is, though, if you are given the area of the measure of the angle in degrees, you're going to have to remember to convert that into radians before you make this calculation. Okay. All right. Let's take a look at a couple of examples from the OpenStax book that we're using, number 22 and 24. So 22 is this one right here. So let me get that set up. And so here they give you a figure to look at, and they want the arc length. So they want the length of this blue arc right here. And we know, right, from what we just discussed, that the formula for that is S equals R theta, okay? And so we're going to do that. And we are given that the radius is 3, right? And now all we need is the measure of the angle. But looking at the figure, they are giving us 140 degrees. And remember, the formula S equals R theta only works if the angle, you use the radian measure, right, for the angle. So what that means is that we will have to go off over here to the side and convert 140 degrees to radians, right? And we've already talked about how to do that. You're going to have to multiply by pi over 180 or 180 over pi, whatever the case may be. And, right, how do you remember which one it is? Is it pi over 180 or 180 over pi? Well, remember the clue or the key is to remember that if this is in degrees, then the denominator here has to be degrees. The units between the numerator here and the denominator have to match, right? So that means 180 degrees is going to go on the bottom, and then pi is going to go on the top here, okay? All right, so looking at this one, you can either multiply and reduce, or go ahead and reduce and then multiply. So it's obvious, right, that 10 goes into 140 and 180, both of those, right? So 10 would be a common factor between the numerator and denominator. And then 14 and 18, 2 goes into both of those evenly, right? So it would be 20, right, would go into 140 and 180. All right, so 20 goes into 147 times, right? And 20 goes into 189 times. All right, and so then we can just multiply multiply across the tops. 7 pi 1 times 9 is 9. Okay. All right, and so the radian measure of 140 degrees is 7 pi over 9. So that goes in here. And then we just need to multiply those. All right, so that is going to be 3 over 1. 7 pi over 9. All right, and you can either multiply and reduce, or I'm just going to go ahead and reduce and then multiply. So 3 goes into itself once. 3 goes into 9 3 times. So we get 7 pi over 3. All right, and don't forget to put the units, right? They're talking about the length. And so the units would be the same units that the radius is specified in. So this would be inches in this case. So it'd be 7 pi over 3 inches. And it doesn't say how to specify our answer. It just says find the arc length. So you can, leaving it like this is fine. But on the quiz or test, you might need to plug that into a calculator and get what that is as a decimal, because that's on the, if you're taking it, some of the online things are going to ask you for a decimal. So I'm just going to use Desmos here, but you could use a scientific calculator as well. So you get 7.33 to 2 decimal places. So that'd be about 7.33 inches. All right, next up, let's take a look at number 24. 24 is very similar, right? It says find the arc length of this. And here you can see they give us the arc length in radians, right? There's no degree sign here, so this is in radians. And so on this one, right, again, we're going to use the same formula, S equals R theta, and this one, we don't have to do any conversion, right? They give us everything just how we would want it. All right, so R is going to be 4.5, and then 2 pi over 5. All right, and on this one, 4.5, again, it doesn't really specify how they want the units, or how they want this answer displayed. Do they want it as the exact value, or do they want it as a decimal? Doesn't really say. Here, though, when they give you something like this 4.5, they probably want it as a decimal in the end as well. So let's go ahead and just multiply that out. It's not hard to turn this into a fraction and do it that way, but that's probably not something you'd be likely to do. So in this case, we're just going to go ahead and multiply it on out. 4.5 times 2 pi over 5, like that, and we get 5.65 to 2 decimal places. And the units, right, are going to be the same units as the radius, right, because that's a distance around the circle there, so it's going to be centimeters in this case. So don't forget to put that on there. Also on the test, right, if you're taking this through our George view, then you might not put the units in there. So on the test and everything, they might not want you to put the units, but it's always good practice, right? Normally you're going to have to specify the units, right, as to what this is. If you write 5.65 down, anybody who comes along later and looks at that doesn't know what units those are written in. So when you're working these problems for practice, it's always good to make sure that you specify the units. You're going to have to do that in other classes as well. So okay, and that is it on this one.